Let's take a look at Zod for a second. We can see that there's a few things to kind of take note of when we look at the site. One is we'll see, I'll look at the sidebar in a moment, but two is scrolling past the sponsors. This is what I want to look at, the ecosystem, right? One of the things that I want to kind of encourage you is if there are other things that you use, there might be libraries for kind of integrating with that, so you can kind of get a lot of things for free. I think more importantly, like, yes, you can use it with like React hook form to make sure that we joked earlier that stuff users type in might be problematic, and having the form validation. So your same schema that you're using on the request body in Express, or like when you're going to get it back from the API, you can also use those same schemas for the forms that your users are filling out. Again, if you use Formic, there's other ones, so on and so forth. There's, for SvelteKit, there's the ability then also to like turn them into JSON schema, or take a bunch of Zod's schemas and turn them into TypeScript types, right? So for a lot of these things, what I want to call out is if there are things that you think you need to do very tediously, it is worth at least checking to see if somebody else did it tediously first, and seeing if you have it as well. There are some other interesting things that you can do that you cannot do in TypeScript. And so, like I said before, there is that coercion, which is kind of nice, which is the ability to say like a string. You can also actually say, but like an email, right? And obviously TypeScript's not going to do that for you. There's some like template literals that you can use, but like the type will be a string, but then you can also actually like make sure that it is truly an email, something, so on and so forth, which is also very useful, again, for when you're receiving it in the API level before you put it in the database, right? You can probably take lines and lines and lines of regex and code and stuff to make sure that the number is positive, so on and so forth, and probably eliminate that as well. But you can, if it's something that can coerce into a string, you can do that first, so on and so forth. And there's also, the ability to do a lot of the utility types that we're used to seeing from TypeScript. All of those are available as well, right? So you get a little bit more than you get from TypeScript, and then you can always like create the TypeScript types out of it as well. Installing Zod is relatively easy. The simplest use case, and we're going to do some examples together in a second, but we'll do the high level, which is like, again, just a string, it will parse a string. Just a number, so on and so forth, right? You can also do things like making sure that it's a date object or a big int. All of the things that you want are in there. You can start to then build up things as well, and then generate those types, like we said. But there's some nice things you can do, which is you can also make sure that it's got a minimum length. Things you can't do in TypeScript, which is, again, because you have full access to the data object itself. Because a lot of times, like, TypeScript couldn't help you if it wanted to, again, if it's outside those walls. You can do literals, so instead of a string, no, it should be the string hello, right? Or if you want to use, this is not technically like the TypeScript version of an enum, but this is like effectively a union of strings. To say like, hey, it should be red, the string green, or the string blue, right? If you have something that can only be a few different strings, this one will throw in all of those cases if that's not. And that's a lot easier than if you had to try to figure out from the type. You'd either have to do that by hand or, again, put it into a data structure and then iterate over it. This, you kind of get it all for free. Other fun things we can do, a tuple or tuple, your choice. I'm not having that fight right now, is to say like an array of two things, the first one being a string and the second one being a number, right? So, the tuple that we probably, or tuple, I haven't decided which one I want to say because it's not a word I say out loud that often, that we see a lot of times is something like use state in React, right? Sure, it's an array, but that first one is always the current state, and the second thing out of that array from use state is the ability to set the state. Right, and so like to know exactly what types those are is incredibly powerful as well. You can also do unions in this case, and so this will be either a string or a number as well. Intersections, again, all of the TypeScript stuff that that you can use as well. But where this gets a little bit more powerful is then you can begin to compose some of these things. Right, and so if you have a schema, like we talked about those nested JavaScript objects, right, you can just reference a different schema for that value of that key, right? Or you can extend one in the same way you might extend an interface in TypeScript, right? And add more things to it, or we can pick things out of it, so on and so forth. So like a lot of times if you find yourself like rewriting the same things over and over by hand, again, keep in mind that you have a programming language and you can like begin to compose things as well. So let's do kind of a tour of what we've got going on here, which is we've got an application where most of our time today is going to be spent in the client and the server folders. Spoiler alert, one's an Express app and one's a React app. Is anything we're talking about specific to Express or React per se? No, but it is kind of like, I felt like the lowest common denominator of things that like, even if you don't write React all day, every day, and again, we're not going to touch a lot of the React code, or Express all day, every day, you've probably seen enough of it before to be at least somewhat familiar with it. We're not actually going to touch too much of the actual framework code itself, but we are just going to have some stuff in there to make it a little bit more real. We've got a shared folder for stuff we want to share between the two of them. And then we have this like weird exercises folder that shouldn't be in this repo, but like making you download 2 repos felt rude. So it's here, which is where we're going to start our life together in this exercises Zod folder here. Where there are a bunch of little exercises that definitely right now need some schemas, right? And so what we'll do is kind of try to get our hands dirty. Like listening to me talk about schemas any longer seems egregiously terrible. So why don't, even if we're feeling like, but I just learned about this, I'm not ready to, we can do it. I believe in you. Also, the answers are like right over here, and I will go after you. Like I will do it along with you in a second as well. But like you're not, you are in a safe space to start playing around, getting your hands dirty. But what we want to do is we want to take away the .to do here, right? And we're gonna do like good old-fashioned test-driven development where it will be a sea of red, and we will seek to make it green, and we will get a sense of that as we go along as well. So. From the main repo, like I said before, there's a few like little kind of subfolders between our client-side app that we'll play around with, our server-side app, some shared folder, and this weird little exercise folder. So what we'll do is we'll head in, from the top, we'll go into this exercises, and then in there I've got this Zod set of exercises. And out of the box, if we just do npm test, not a lot happens in this case, right? We've got some passing ones, but the ones that we really want are skipped to this point. Pro tip, if you only want to run one file, you can kind of type in some of the name of it. So we can do like Zod exercises .test. So right now they're all skipped, which is intentional. They are called .to do. This is so the test didn't blow up because we haven't done anything yet. So you can remove that. I put some little mini ones in here just to kind of like slow myself down. You can do that, you cannot do that, it's up to you. But we'll kind of get each one running one at a time. So, like I said, by definition, this is going to fail because one, it's not a Zod schema at all. And TypeScript has nothing to say about it because you said that it's, or I said, we said, it was said, that we're gonna mark it as any, so this code will legit blow up, right? And in our test suite, any blow up technically counts as a test failure. So going ahead, I can kind of take this first suite here, and I'll remove that to do, and we can see it has blown up out of the box, right? There are some that are expected to blow up, right? So we'll play that game in a second. So basically what we want to see is our basic schema should be able to kind of work with a type that has a name as a string and age is nothing but a number, but that number should be at least a positive number. Like you cannot be -5 years old. You can act like it, but you probably can't be it. So let's write our first Zod schema together, which is, again, we know this is going to be an object. And in this case, we can say, yeah, name is a string. and the age. We have a few options. I'll show you a bunch. Let's make sure this passes first. Okay, it passes. So we can say number, and we get a little bit more granularity than TypeScript would normally give us, because like in TypeScript, there is a type for a number. That number could be a negative number, a positive number. It could be 3.67, right? So Zod does give us the ability to put some additional checks on top of that. So in this case, we can say it's a number, it should be a whole number, an integer, and it should be positive, right? Another way that you could do it, you could say something like min is 0. That will at least get you to the positive number, right? And again, like it all depends. Like, do you insist that the age is an integer or not, right? Like, I don't personally. If I'm going with the assignment as given, like this technically fits the assignment, but you could also do the int, and these are kind of just, as you can kind of see, like refinements on that initial number. So as we can see, they all pass. And just to kind of show you, I could say like type user z.infer, and this is that utility type. I could say type of. And so now if I look at this type, you can see that it did a pretty good job of coming up with the TypeScript type out of the box. All right, so we wrote our first Zod schema. We're killing it. We're doing great. Awesome, and so these all pass. We can go down to the next one. Okay, so for my next one, I want to have an optional number, right? Okay, so let's go ahead and get these failing. And we'll look at two different ways we can go about this. So we can go ahead and, again, we know it's going to be an object. And we know the name is going to be a string. So a few things you can do here. That's a little more than I wanted for the first pass in this case. But I like it, and we're going to talk about it anyway. So we're going to say that name is a string. Number is, again, a positive integer. In this case, we can also say that it's optional, right? And that if it doesn't exist, we do want a default value to it, which is nice. So it's like, if that is not on there, maybe 0 is a fine answer. Now, the big question is like, the logic of whatever you're trying to implement. That is either the behavior you want or not the behavior. My job is to show you that it's an option, and that you can do these kinds of things. We do have a failing test. Let's see which one fails. Interesting. I have, I'll show you the one that I did earlier too, right? Because this is like the autocomplete one. But this one we did not get, the default is 0. I'm curious if it has to do with the chain or what.
I have number, min, optional, default.
Number, min, optional, default. All right, let's put it back in the middle there. Or the transform works too. Hey, we all learned something together, which is the order matters. Cool. So now, not only did we achieve the core part of having optional and values in there, we also learned a little bit about the ordering along the way. Cool. And so it goes through and it does all these things. Our third challenge, this is one where we can reference other ones as well. One thing I do want to show real quick is, again, I think I deleted that other type. So we can see, again, what the type is in this case, which you'll notice that it does say that there is an age property because we fill it in with a default, right? If I got rid of this, you can see that now it is actually an optional prop in the type that was created as well, right? Because whatever gets parsed when you have a default value, you would have always got a number. So now TypeScript's not going to yell at you about like, are you sure this number is possibly undefined? You're like, no, because I made it 0 or an object or whatever. So
when doing this, would you create your types in just that way?
It depends. Sometimes I already have the types, right? And so like, which one, like I have to go the other direction. If I don't have the types, then yes, right? But sometimes it's like the types were for, like when we're gonna look at like either OpenAPI/Swagger docs for like that will generate an API like schema for you. Like in some of those cases, you might have the types from somewhere else, or you might have, especially if you're sending it to, like if you have the types of like a third-party API or an SDK or something along those lines, you might have the types but not the schemas. If you don't have either, then this will work because again, like and you can write tests against it, right? Are there ways to test types in like various testing frameworks like VTest? Yes. Does anyone do them? No. Do we more likely test regular JavaScript? Absolutely. So it depends is the answer, unfortunately, which is the answer for a lot of things. So, awesome. So yeah, then like having ones that refer to other schemas, like we kind of talked about before. So we can go ahead and, I kind of have at least the end state that I'm looking for, which is a person will have a name and then they will have some array of addresses, right? And TypeScript's types are nice because they are all just kind of hoisted and stuff along those lines. You do have to follow the rules of JavaScript when writing JavaScript, which is like order matters, right? You can't reference stuff until it's defined. There are ways to do it. We'll talk about it, but like we're not there yet. So an address schema seems to have a city, street, zip, apartment number. That's optional. So, and we can kind of play with some various options here as well. So we've got this object. Street part is easy. The city part is easy. As you can say it's a string with a length of 5. You can then also like provide like a regex to make sure that it's like 5 numbers, right, as well. Which is nice because like you can't really do that in TypeScript. You can say it should be 5 numbers, but those numbers could be lots and lots of digits. So like to say 5 actual digits is kind of nice as well. And here we want to say that it's optional. And again, you will get a type. But the nice part is one schema can very, very, very easily reference another schema. So in this case, we can say that a user profile is an object, and it's going to have the name that's a string, and then an array. But you can see I'm just referencing if it had one address, I could literally say that address was like legit, just point to the schema, and like those nested objects will all just work, right? So like if you find yourself like you can reuse stuff, you can kind of like compose one thing out of another, so on and so forth, right? And so we go through. We make sure it doesn't throw as we validate the things, so on and so forth. If we add one where it's not like too many numbers in it, or in this case, too many, obviously it will fail, so on and so forth. Cool. Moving on to this idea of like a union. And so in this case, right, like we want either the string literal anonymous or an ID and a name, right? And so in this case, we could make this one thing or not. It's up to us. I'm actually going to break it up into 2 just to make my point. Anonymous schema, this way it could be a literal. So it's like, we're not saying that it's a string or an object. We're saying it is literally the word anonymous or one of these other objects. I can make that anonymous schema as well. And then for the user identity, I could do something like, actually, let's do a user schema as well. And like a different way of doing this is in the answers, but I've decided I hate myself and that I'm going to live code and, be a cowboy about this. So here we'll say that the ID is a number and the name is a string. And so what we could do in this case is literally say that this is a union between those two, right? And again, I gotta make sure I delete these so they don't like conflict, but I think I'm good. Now, if we look at this, it is either, that's user schema. I want user identity schema. So it's either the string anonymous or the things I'm expecting it to be. So now, what if we wanted to refine something? Again, like in TypeScript, we don't get a lot of programmability, right? But in JavaScript, you can program things. That's the selling point of JavaScript. So, I've got a stupid little function here, which is like a way, like is prime. So if we wanted to have it only allowed to be prime numbers. If the question is, why would you want this? I don't have an answer for you, right? At some point, when you get on to challenge number 5, the coffee starts hitting and you get creative all of a sudden. So how do we go about doing that? We can go ahead and kind of take one of these things that we saw before. So in this case, we want a prime number. So we can do that z.number. Because they don't all have to be objects. That said, if it was talking and typing at the same time. If it is just a number, you could argue, couldn't I have just done type of number? You could have, or type of equals string. Yes. But in this case, we can also do a few more powerful things. And like with the kind of putting it all together and nesting it becomes interesting as well. So we'll say refine. The one good thing about Copilot sometimes is that like if you've done this enough times in the same repo, because you have a branch called main. I have a branch called dry run and practice and rehearsal, and people will think I'm live coding, but I've done this 1,000 times. And so it has been trained on those on mine. So if your suggestions are not nearly as good, it's because I have put in the hours. Cool, so I don't like that suggestion though, actually. Okay, so we'll say is prime. So it'll first check to see if it's a number, and then it will like pass that number through this function to make sure it is what you think it is. So again, probably like also useful for a string of a particular format, a string that matches a given regex, right? If we wanted to, I don't know if there's a built-in helper for a zip code, but you could refine it to say, yeah, it should be a string. It should have a length of 5. And also it should be, match this regex where it's 5 numbers, right? Or it's a zip code and I'm totally cool with it being 5 numbers, or a hyphen and then 4 more digits for a US longer zip code, so on and so forth, right? Like the idea that you can like add that little extra stuff. And again, like trying at that point to save you a bunch of other things as well. The other thing that we'll do here is you can see this error is like, that's unique, right? And so like we are throwing, if I just turn this into like to throw, can I take that out? Like it obviously throws, but you can actually define more helpful error messages. Why would you want to do this? Okay, it didn't validate on the API level, and I want to send back a 400 with like actual helpful information that is not like me just leaking Zod error messages all over the place, right? You could then include those messages in, that error message in the 400 response. Or you're using a Zod schema for form validation, right? And you want to like, be able to say like, hey, for this input field, this is, email address must include whatever, right? That's not a valid URL, so on and so forth. So you can always, like for a lot of these, also add in a message, right? Cool, and now they pass. All right, the transform, we can kind of take a look at as well, which is, there are lots of things that we deal with that do not serialize into JSON super well, all right? And a lot of times we can't send full-on JavaScript objects over the wire. We can only send JSON that we can like rehydrate back in there. One of the things that usually comes up is a date and stuff along those lines. We do want to make sure that at first it's a string, right? Because otherwise, what am I transforming, right? And we could say like it's a string or a date already. I don't hate that idea, but like I know that like in this very fictitious example, it's coming back as from a JSON API. And the cool thing is, because you already validated that it's a string, this value here is typed as a string, right? So it's not unknown. It's like you've already figured out part of what it is. You know it's a string of some sort. Right, so now TypeScript has already inferred that it is a string, and you can kind of like move on with your life. And so now you can like create a new date out of it in this case as well. And so, because again, it's a string, we hope that when we have new date, if that ends up with like something invalid, then we know that it was not a date, right? Because like we checked to see. Again, libraries like SuperJSON will also do something very similar for you in terms of doing that coercion, but it's pretty cool to be able to do yourself in a pinch if you don't want to pull in another library. So let's make sure that as I was talking and typing that I was not doing things that were silly, right? And so like if you check it out, we parse it, and we know already, like if you look at the TypeScript type, it has already inferred this is actually a date, right? Just by the act of parsing it. And then I check it 1,000 more times. And we can turn it back into a string if we want to. Great. And like if it's not a date, we throw with like our own special error message, right? If it throws, that's how you know it didn't pass the validation, right? All that safe parse really does is it puts your parsing in a try-catch block. That's it. Throwing is the act of failing. Okay. There is a concept in TypeScript called a branded type, which is, and I'll kind of show you what that is in a second. So kind of just put the answer in the assignment on this one, but I think it's because I wanted to show it at the time. So we've got this user schema, and then if we look, it's like string and brand is user ID, which is, this is a TypeScript trick, which is if you want to say like, I went through a lot of work to make sure this string is an email address or this string is a UUID. TypeScript's like, cool, it's a string, right? And so a lot of times you'll see this move of, and there's a bunch of different ways to do it. It's a string and like some weird metadata that doesn't like really exist, right? And so now if something says, in this case, like X is a user ID, and I just give it a string, you'll see it's like, hey, no, it needed to be a user ID, right? And so you do something like, I'm going to check to see if that string was in fact a user ID, and if it is, then it'll match that type. It's like, this is not necessarily a Zod thing, it's a little TypeScript trick to make sure like, because again, TypeScript only has a string type, and this is a way to say, but my special string. But then you will always have to check to make sure it is first, right? Even if it is a value from anywhere else in your code base, you will have to like do some logic to confirm that it is in fact a UUID in this case. But it works. Like we said before, there's this idea of pick, partial, omit. Why would you ever want to do this? Very good reasons. You might have, we're going to build a to-do list as I discussed, right? A task that's in the database has an ID, right? One that you are just creating, that you're sending to the API, doesn't yet. So like, you might only want parts of it. But then like, what happens if we want to update the object? Do I want to make them pass in the entire full object again? Or do I say like, give me a subset of the properties and I will update the object? So a lot of times, they can all be optional because as long as I get an object, if it's all empty, then we do no updates. If it's everything, we update everything. Or maybe I want partial of everything, but like, the ID can't change, right? Some of these tools make it a lot easier to do that. So with a full user schema, in this case, what is this one expecting? So we've got the kind of earlier one that we wrote with the addresses, so on and so forth. Cool. Oh, look, use my address schema from earlier. Isn't that nice of it? Great. And so here we've got that full schema. And then a partial, so say give me a version of that that's all optional, right? Because if we look at here, we say type user. You can see that's, in this case, every part of this except for the apartment number is in this case like required. If I do the partial version of it, we can go ahead and say partial is just going to be full user schema. You can see there's some methods on it. Full user schema dot partial, right? And so this is obviously, if you look, it looks complicated, but if we look at the type that came out, if we say something like type partial user, now you can see that all of the properties are optional and they can be undefined, right? Cool. And so let's say we only wanted to show like the names and the addresses or something like that. right? Which is, it's in the test. My font is very big right now. So we'll do like full user schema dot pick, and we'll say the properties that we want. And the nice part is, like, if you try to put a bogus one in there, it knows that that's not on the type, right? Zod is doing under the hood, kind of updating types as it goes along. You can't put in fields that aren't there because it's already, it knows that in that way you're extending that full user schema from earlier. Cool, or one without email. So it's, dot omit. And so this will be everything but the email field, right? So you can start out with, like, you don't have to necessarily make a whole bunch of these by hand and update them all one at a time, so on and so forth. You can kind of take a base and then derive and refine the other ones from that. Cool. All right. Then we have a fun one. This one I use far too often for this exact purpose, so I wasn't even particularly feeling creative at this point, which is sometimes you need, we said there was that email, there was UUID, but sometimes I want something like a hex color, right? Or an RGB or something along those lines. And I need to make sure it's that kind of string. Again, TypeScript's not helping me so much in that case, so I can do something like this as well. So we'll say that this is a z.custom. And you do have to give it like some kind of hint into what it can expect, because like you're totally doing your own thing. You're like, it should be based on a string, right? Make sure it's a string first, or assume it's a string. And then, some way to say that it's a hex code. You could, whether it's a regex or whether you want to check it in other ways. I think this has got to be 3 or 6 according to my tests. He says, I'm live regexing now. That's going to go real well for me. No, it didn't. Cool. Oh, that's between 3 and 6. That's like live regexing got me. We'll say either 3 or 6. And so now this will verify that it is, it'll work on a 3-digit hex color. It'll work on a 6-digit hexadecimal hex color, but it will fail if it doesn't have all the various things. You could do this same thing for like RGB colors, anything in your code base where it's like, it's got to match this exact thing. I got a lot of rules on what this thing ought to be. The nice part is I can make this schema once and use it and reference it in all my other types and never think about this again. I now have a way all throughout my app to do this as well. And like previously, if I was just using a type guard function, I would probably have to validate all the time, all over the place. Is this actually a hex color? Right, now I can say that if the large object passes, it will automatically be typed as a hex color in this case.
What does that get inferred into?
I'm pretty sure this one will get inferred as a string, and I had to brand it. So that's a great question. Let's see if I can do it live. Let's test me. And so it is a string, but I think I can do a dot brand. Yeah. And give it the brand of a hex color. And now it is accepted wherever hex colors are accepted. It is like, it obviously is also a string, right? And so anything that accepts a string will accept this hex color. And then anything that's like, no, it's got to be a hex color. This is now accepted wherever hex colors are accepted, right? And so you can do that branding very easily as well, right? And that's just a utility method. You saw the other way that I could do in the comments as well. But incredibly powerful pattern just for just general TypeScript use cases. All right, and then finally, like this one, we will probably just hand wave over a little bit because it is a culmination of a bunch of things, but the ability to kind of like pull them all together and have a bunch of different pieces that you use that you can then make useful as well. Let's just look at that one because I think watching me type that is like not that fun. So here. So in this case, like we can break it out to being like, okay, you know, a username with the arbitrary rules that I made of like 4 to 16 characters. Password's got to be a string that is minimum 8, right? And then I can test to say it has to have at least 1 digit in it. Obviously, you can take this to its natural conclusion as well. And then you can say what error message it should throw if that didn't happen. Again, you do have some of these built-in ones. We can take a look at the sidebar in the docs. There's email. There's definitely IP address, UUID, URL. Those are the only ones I've ever used. So there's probably more too. Yeah, and a birth date is, again, we're going to make sure it's a date. I could have probably grabbed that date one from earlier as well. And yeah, this is the same one we saw. And then this registration form is just basically built out of these other schemas, right? So I don't have to do this all the time. I can get some of those primitives in place and move on with my life. So then there are more advanced use cases. So why don't we spend another few minutes? We're going to dig into the other ones because like at that point we will stop with the like training ground of Zod schemas and we'll actually put it into practice. But I think like getting our sea legs under us and then taking a run at it in the real world application, we will be better prepared in our journey together. So like I said before, you've got my notes, you've got the docs, we'll do it together and I'll show you some of my feels on what I thought of all of the advanced ones were the most useful. You might need other ones in there and have to like in your day-to-day life, but these were from like, again, the very scientific way that I reflected on who's hurt me at 2 a.m. by changing arrays into null back in engineers. It's never the tools. These are the ones that I find myself reaching for the most. So take a look and then we will try it out together. All right, so we covered some of the basics together. There are, like, again, my small selection based on feels of what some of the more esoteric but like useful enough that I felt compelled to include them schemas are, because going through every single one of them would be boring, right? And so kind of take a look at a few of these. One of the problems that we have is JavaScript is hard. Shocker. And so if we wanted to have like a category that could have subcategories, we're going to come up with a little bit of a problem, right? So I could try to do something like, and as you can see, I kind of hid the answer in here as well, but we could do something like, no, don't give me the answer yet. I'm trying to make a point. Where we have an object, where the name is a string. And then, like I said before, we can reference other schemas, right? And that is normally a okay way to handle this, right? Category schema. The problem is not a Zod problem. The problem is JavaScript's angry with me, right? It's like, you can't use it before it was defined because, you know, it's evaluating at this point before it assigns it to there, right? So it's like, you can't use this because it's not defined yet because you're currently in the process of defining it. So what we need to do is figure out a way to tell Zod to wait a second. Because if you wait a second, then it will be defined. And so, again, the hint is hiding literally in plain sight. What we can do here is say z.lazy, which takes a function, right? And just in the nature of the way that JavaScript works, like, this will be defined and then it will call the function. Right, and so at that point, category schema is now, in this case, defined, right? And so also if you want an array of something, which I should have probably put in the basics, but didn't think about it until just now, but we did it anyway, it's great. So now you can kind of have this thing where you can have a self-referential recursive version of it as well. You just have to, you know, if you don't have the value just yet, wait a second, and then JavaScript will figure it all out. Let's take off that to-do. And it's going to blow up on me because I've got all those other describes. So I'm just going to, there's only 5 in this challenge, so it'll be great. Multi-cursors for the win. Great. Oh, I'm only running that previous test file. So Zod Exercise is advanced. All right, so that one passes, and we're good to go. And again, just to make my point, because I think it's worthwhile. For the ones that are lazy, it can't do it for you. So then you do need to give it a little bit of a hint as well. And I'm trying to remember like how to do it off the top of my head. This point, you might need to know the type first. I will look it up in a second. I've done it enough times before, but I'm now forgetting exactly how to do it off the top of my head. So we've got that one. And okay, so the other one that's kind of interesting is something where we might want to pre-process the data a little bit first. And so the challenge here, if I scroll up and look at it a little bit closer, is I want it to either be this object that I think it is, object that makes a schema, or like a JSON string that is also could be that object. Do you know what I mean? So either like the object or the JSON representation of that object, right? And I need to do some amount of pre-processing to, like try to, like if it's a string, try to turn it into an object and then validate it. So now what's really cool is you can kind of like save yourself the JSON parses, right? You can just put it in the schema. Now it'll either be the object or the string that represents the object. Either is fine. You will get the object at the end as you processed it. It will have the right type. You will save yourself a whole lot of other sadness. So let's take a look at how that might work. So we've got this z.preprocess. And that starts out with a function that's going to take something, right? In this case, we've got an input unknown because I don't know what it is just yet. And I am kind of insisting right now that it is, I did this like looking at my own notes, that like starts and closes like that is an object. I'm not sure that that's incredibly important. I'm sure like, because theoretically this will throw if it wasn't valid JSON and maybe I was just being a little over the top. But we'll experiment that together. I've already gone off the script enough times and suffered, so we're going to stick to the script, and then I'm going to go off script. It's going to be great. So we've got the ability to pre-process it, and then I want to make sure that it is the thing that I think it is, right? So then I can want to say that it's like, in this case, what is it? What am I expecting it to be? Let me check my own test. Cool. Should be an object with the type JSON, the data value 42. Great. So we'll say z.object, and the type, I believe, type is literal JSON, and the date is a value of a number, and I got to close my curly braces or regular. Awesome. And so basically all I'm doing, I think I can get rid of this part, we'll find out together, is if it is a string, parse it as JSON first, right? And then go check the object itself. So now it'll kind of hopefully work for both. We'll find out together if I made a boo-boo. Cool. Didn't skip, so yeah, we should be good.
Your top describe has a to-do.
Where did I thought I got rid of that one. We're gonna find out. Oh, did I add it back? Why did I do that? This is why you live code with all your friends. All right, so which one is failing? Okay, yeah. An actual one that should be failing because I didn't get to it yet. So you love to see that. So I also want to if I want to, or it can have a prefix. That test seems like a bit much. Let's find out if I could have this whole time not checked anything about the string. So I got to at least check that it is a string in this case. But I don't think I need to check for the curly braces because like it will pass this phase, but I think that then the schema validation afterwards will fail. Or I did it for a reason. Oh yeah, so you can just parse it first. So if it's a string, parse it, move it on through, and then we're going to check the object that comes out the other end. The test that failed is apparently a previous version of me wanted to make a union where something could also start with the string prefix, which is probably why I made it more complicated as well. So I'm trying to think if there are other fun ones that we need to look at. Yeah, so this is sometimes you need to do something asynchronous to figure out if it's valid, right? The example I came up with is like if it was a form, you want to be able to see if it's a valid username by checking to see if that username is taken. In like this case, like I will have, just like a silly little function that returns a promise because it's an async function that will tell me whether or not it's taken. Right, but this could be hitting the API, something along those lines. When would you use this one? Most likely like form validation, or maybe to see that like, is that ID taken already? Something where you need to like confirm what's the source of truth, whether or not it's valid beforehand, or anything asynchronous. Which theoretically, I guess you could also like go fetch that data and then check it all yourself. But then again, now you have the schema, it will go check the thing. You will be happy, life will be great. So in this case, what we can do is we can go and kind of just use refine to kind of get a sense of whether or not it works. So what we'll do is first, we do need to make sure it's a string, right? That seems totally fair. And so we'll say z.string, and then we'll refine with a asynchronous function to like make sure that that username is not taken. Again, like this would call an API. I did not decide to set up an entire server for this. As well, let's make sure that passes. Great. And so now you can do asynchronous things. You can validate. Most useful thing there is like the parts where you might do form validation or something along those lines. But I could definitely like riff on different places I would use on the server side as well. All the places that I have used it are very, very bespoke and weird, not worth talking about, but like it comes up. You can look at some of the errors. I kind of, in the name of brevity, the one that I also want to get to is the one I talked to in the beginning, which is like, again, the answers are hiding in plain sight, but the ability to use this coerce first, which is to say like, if it's anything that can coerce into a number, it'll be valid. So like the number 100 will be, or just as valid as the string 100, right? Because query params are always strings, like even in the browser or in Express, and like a lot of times you'd be then casting them, and you kind of a lot of times hoping for the best when you like put a plus sign in front of the string and just hope it turns into a number, or like a parse int and hope for the best, hope it's not nan, which will technically be a type of number, so on and so forth. So like in this case, it will allow you to say like, again, 0, 1 will coerce into true and false if you're looking for a Boolean. Like a string that matches a number. It is all this stuff where it's like, sure, close enough, but like, as long as it can become the thing. And the nice part is you will get the number out in this case. You will get the Boolean. It will like fix everything. And this can work the other way. If you say z.coerce.string and you pass in the number 2, it'll pass and you'll get the string 2, right? So like a nice little convenience method as well. Cool. And as you can see, like it doesn't throw on the string 150. It does in this case throw on 50 because that's less than 100. So you kind of got like a whole bunch of stuff for free in one very simple line of code. And again, it will throw if you give it A, B, and C, right? So numbers that are number-ish, and you can validate it based on its number-ishness, like that's a technical term, will pass. What did we just do? We walked, again, there are a lot more methods to Zod. I think that we're probably at our capacity, for walking through method by method. But the important part is now we have at least one very important tool for enforcing that type safety wherever we are. Especially like if you're in the case where, it's a Node backend and your client-side app, you can share these schemas in the same place. Now you can both like parse the request body with the same thing doing the form validation. You can, for the response coming back from the API, you can make sure when it came out of the database that it is what it should be before you send it as the response. And then when it gets to the browser, use the same schema to make sure that it is the thing you think it is. And even if you didn't share the types, like Zod is going to infer the types for you. Like you can do that z.infer, but like also they will be of that type. You will get all the autocomplete. You will get all the IntelliSense. You can use these same things all over the place. So you can validate the things are what you think they are on the server side. You can validate the things are what you think they are on the client side. You can validate it before and after it goes in and out of the database, right? Before you write it to the file system if you're saving JSON files or using like Mongo or something like that, right? You can use the same schemas literally everywhere. Either if you didn't even share the types, you can go ahead and like, infer the types out of it. And like I said before, when we looked at the Zod documentation before, right? Like obviously Zod itself is a set of, it's JavaScript, right? So it's not easy to serialize, right? And just like put into a JSON file. But you know what is? I don't know why I'm like live scrolling in front of y'all. A JSON schema is just a JavaScript object. So you could, in either a shared repo, or honestly, you could like host it somewhere, or in either the server repo or the client repo, like turn your Zod schemas into JSON schema and just have a file you can pull down and get those types on both the client and the server and the data layer, right? Like you can just serialize them into a JSON schema object. You can either turn back into Zod or what have you. We'll also kind of do this with Swagger docs later as well. And so now we have the first like piece of our toolkit for giving ourselves type safety across our entire stack, which is the ability to kind of like enforce the same schemas and the same types wherever JavaScript is sold, right? And we'll, obviously if you're using other languages, the Zod stuff won't work, but you can find, if you serialize it down to the JSON schema, then you will go ahead and like have the ability to like turn that into what in Go, Python, Ruby, what have you. The other thing that I promised to answer, which is what happens if you start out with the type. And I opened that page earlier. So let's say I had the type and I'm trying to write a Zod schema that matches that type. There might be a better way to do it. This is my trick that I think that I invented. Unclear if I actually invented it or if other people use it or if there's a better way to do it, but this is what I do, which is you can write the schema and then you can say satisfies with modern versions of TypeScript. I think TypeScript 5 and later, 4, I don't know when satisfies came out, but like in any version of TypeScript in the last like 4 years or something like that, you should be good where you can say like, hey, and it satisfies, and you have to use this Zod type, that type, you'll get a red squiggly lines of sadness if you don't match it. Let me prove that to you. Did I not copy the test? You gotta copy all the things. If you're gonna copy and paste from your own notes, you gotta do it all. All right, so right now it's good, it works. If for some reason, like, I don't know, I added, or let's change this to be a string. Right, now the TypeScript won't compile. So you can be confident that whatever schema you came up, again, because if we don't trust the types that we wrote on a fetch, we shouldn't trust it for making our schemas either. But at this point, TypeScript and Zod will work together to ensure that you did the good thing and you did the right thing. And so that's how I do it when I have the types, but I don't have the schemas, right? Because the schemas are useful even if you're never generating types on it, because I can now say, like, hey, did I get the thing back from the API that I thought I was supposed to get, right? Did I, or if it's going to be one or two different things, you can use that safe parse, right? And have a conditional, right? And then cast it that way as well. And be like, oh, this could be one of 3 different things. I'll use schemas a lot of times. I won't use the try-catch version. I'll use the safe parse version to like say, if is this thing, if is that thing, do the, and so on and so forth. So it's super useful for that as well. So a lot of times I will make schemas reverse engineered from types I already have and trust because I want to use it, because I don't want to write those like gnarly type guards that you saw earlier, right? Because my code base is open source. You can find my sins. There are some egregious ones that I have done. And yes, I did in the year 2021, and I have not refactored them yet. I will do it, I promise you.